Okay, today we are going to do the probability practice, which is just covering probability. It's got a few review questions in it. So to start, it says a game's card set is made up of 6 blue cards and 9 red cards. If a player randomly selects one of the cards, what's the probability it will be blue? So to do this problem, you need the total number of cards. So total always goes on the bottom. So if I look here, I have 6 plus 9. So that is a total of 15 cards. And then we are selecting a blue card, and it tells you that there are 6 blue cards. So the number 6 goes on top. But notice how 6 over 15 isn't an answer choice because that can be reduced. So 6 over 15 reduces to 2 out of 5. So you have a 2 out of 5 chance of selecting a blue card. Always remember to reduce probability. Okay, and number 2, this one always seems to give some problems when you're reading it because you're like, well, how many pens are there? So number 2 says there are twice as many red pens as blue pens in the desk. If a pen is randomly selected, what is the probability it will be blue? So I like to kind of make this one visual. So here's a blue pen. There is 1 blue pen. If there are 2 times as many red pens, if I have 1 blue pen, that means I have 2 red pens. In this case, they're pink. It says, what is the probability of picking a blue pen? Well, I have 1 blue pen out of 3. And you're like, well, what if that only works for 1? Well, let's say we have 2 blue pens. If we have 2 blue pens, then we should have twice that for blue or pink or red or whatever. So there are 4 red pens. Well, the probability of picking a blue pen is now 2 out of 6, which reduces to 1 over 3. So notice the pattern here. It doesn't matter as long as we know, okay, there are, twice as many blue or red versus blue. So like red would be like 2B, and blue we could use as the letter B. So underneath, the total is 2B plus 3B, or plus 1B, which is 3B. And I am picking a blue, which is B, and that will always reduce to 1 over 3. Like it will always reduce to 1/3 of the pens being blue. Number 3, the probability of randomly selecting a green marble is 4/5. If there are 110 marbles in the bag, how many are not green? That is important because when you're solving this problem, you are going to be solving for green marbles. So you have to remember you're looking for not green. So to start this problem off, you know that there are 4/5 marbles that are green, and there's a total of 110. Well, basically what they've done is they've unreduced this fraction. So I'm going to put the letter G to represent green, and I'm going to figure out how many green marbles are actually in the bag. So 4 times 110 is 440 equals 5G. And when I divide by 5, I figure out that the green marbles, there are 88 of them. E is not the answer. I want to know how many are not green. So I take my total of 110, subtract the number of green, and I'm left with 22. And these are my not green marbles. So there are 22 total. Okay, so to do this kind of problem, all you have to do is know, okay, well, how many green are there? And then you figure out how many not green from here. Okay. So setting up your ratio, you should know, okay, I know that there are 88 green marbles, so I want to subtract 88 from my total. You could also do it this way. So you could also do this one other way, and I'm going to kind of do it in a different color. So if you know that 4/5 of your marbles are green, you would know that 1/5 of your marbles are not green. So if you know the total is 110, you could multiply them by 1 over 5 and you get 22. So that's an additional way to do this problem. Let me go ahead and break that off. So whenever you're looking at the answer key, you kind of can see, okay, there's 2 ways to do it. You can use fractions and multiplication, or you can use proportions and cross multiplying. Okay, number 4, the coin problem. So it says a fair coin is flipped 5 times and each time it has been tails. What is the probability that it will land on tails on the 6th flip? Now, notice how it's not saying it's landing on tails in a row. It's saying that, okay, when you flip these coins, the probability of it landing on heads or tails, it's always 1 out of 2. Like 2 is the total. You can either be heads or tails, and we want it to be tails. Like 1 out of 2. It's always 1 out of 2. These probabilities are independent of each other. So that does not mean, hey, I don't want tails in a row. I just want to know when I flip this coin on the 6th flip, will it be heads or tails? It's always a 50-50 chance. Number 5. I don't know where I'm getting these numbers from. Number 5 is actually testing, do you understand prime numbers and do you understand probability? So it says a number is randomly selected from numbers between 1 and 25, inclusive. They put inclusive there, so you think that you're going to use 1. You do not use 1. It says, what is the probability that the number is prime? Well, you know that you're working with a total of 25 numbers, and I'm just going to list all my primes. 2 is the first smallest prime. 2 is also the only even prime. So 2, 3, then I jump to 5, 7, 11, 13, 17, 19, and 23 for a total of 9 prime numbers. Remember, prime numbers are numbers that in order to multiply, so in order to get 2, I can only break it down to 1 times 2. Like that's it. And same goes for 5. So remember, prime numbers, all that means is I can't break it down. I can't multiply to get 5, anything else other than 1 times 5. So that's what a prime number is. And 2 is the smallest prime number. All right, number 6, what is the probability? The possibilities of 5 events are listed on the table. What is the event that is least likely to occur? Well, the one that's least likely to occur is the one with the lowest probability. So if we're looking for that, the lowest probability equals the least likely. If I'm looking for which one's not going to happen, I'm going to look for the one that's the smallest probability. Well, the smallest probability is 0.25. These other ones are bigger. So event number 1 has the smallest chance of happening because its probability is the smallest. So look for the lowest probability, and that will be your least likely to happen. Number 7, 2 contest winners are chosen by having their name drawn out of a hat. One name is drawn and is not replaced, and each person is allowed only 1 entry. In a total, 7 people have entered the contest. If Sarah's name has not been chosen on the first draw, what's the probability they will pick her on the second draw? So Sarah's chance, she is 1 out of the 7 ticket holders, okay? She has the opportunity to win first. However, she did not win. And when they draw a name, it's not replaced. So in this one, Sarah did not win. Her ticket is still in there. She still has a chance. However, there's not 7 tickets anymore. There are 6 because it is not replaced once it's been taken. So now her ticket still remains, but the total has gone down by 1 because we've already selected a ticket. So it's option B. So to go from here to here, we have 1 ticket that's gone. So like she still has her chance to win. Number 8 is a tricky problem, but mathematically it's not that bad. So I'm going to kind of scoot over here to use this room over here to assist me. So it says only 10th, 11th, and 12th grade students attend this high school. The ratio of 10th graders to the school's total population is 86 to 255. So for 10th graders, there are 86 out of 255. So we know that there are 255 kids total. The ratio of 11th graders is 18 to 51. Here's the thing. They purposely have given you a reduced fraction in the hopes that you don't know what to do. We're trying to figure out, okay, if I get to pick between the 10th, 11th, and 12th graders, which one am I most likely to pick? Well, in order to find out how many 12th graders there are, I need to actually unreduce this fraction. So we're going to do just like what we did with the similar, I'm going to put an E for 11th, for the green marble question, number 2. It's the same idea. So I'm going to cross multiply. So 51 11th graders is going to equal, let me get my calculator real quick, 255 times 18, 4,590. And when we divide by 51, there are 90 11th graders. So in this problem, there are 86 10th graders, there are 90 11th graders, and to figure out how many 12th graders there are, I know that the total has to be 255, and I'm going to subtract 86 10th graders minus 90 11th graders, and I'm left with 49. So there are 49 12th graders. Well, if I'm looking for which one is most likely to happen, okay, which one I'm most likely to find, it's the one with the highest number. So 90 is the largest number, so I am most likely to choose an 11th grader because there are more of them. They want you to pick can't be determined because they give you this fraction without the same denominator, but don't let that fool you. Just calculate, unreduce the fraction, make a proportion, and that will help you find how many total 11th graders there are, and then go from there. All right, number 9. Oh no, I just realized that I have worked out some of the problems in this packet. I probably should have checked that before, so let me grab an eraser real quick. Okay, I just grabbed a new one. All right, so here we go. Number 9, it says, Hannah and Jake are hoping to get asked to host this year's talent show. The committee chooses the host at random selection, and this year there are 29 students entered into the drawing to host. What is the probability of either Hannah or Jack being selected as this year's host? Now, in this problem, this is either or probability, so it doesn't matter if Hannah wins or Jack wins, they're going to be happy. So Hannah has a 1 out of 29 chance of being selected because she's 1 out of the 29. Jack also has a 1 out of 29 chance of winning. However, we don't care if Jack or Hannah gets picked. We just want one of them to win. So anytime it's or probability, you add the probabilities together. So 1 plus 1 is 2. And when you add fractions, the denominators stay the same. So there is a 2 out of 29 chance that Hannah or Jack could be selected out of the total participants. Number 10, a set of numbers contains m numbers, one of which is even. If a number is randomly selected from the set, what is the probability it will not be even? So we're looking for not even. Okay? In this problem, there is a total, and the total number is represented by m. Remember, when we talk in terms of probability, the total always goes on the bottom. Now, we know that in even numbers, there is only one even number. Now, it's not saying that number 1 is even. The number 1 is odd. But it's just saying quantity-wise, there is one number that we can consider even. Okay? Well, if I want to figure out what not even, how many are not even, that's just another word for odd. Well, if I take my total and subtract all the even numbers out of it, the only thing I'm left with is an odd number, right? If I take all of them out and I remove the only even, I'm only left with odds. Well, let's kind of think about this in a new way. Total is represented by m minus even, which is represented by 1. And that's going to represent the odd numbers. So if I'm looking for the ones that are odd, I take my total and subtract the only even number, which is option D. All this is asking you to do is build an equation. If you pick option A, that's how many even numbers are in the stack. Okay. Number 11, 3 telephones in a shipment of 8 are known to be defective. So let's write that down. 3 out of 8 They are defective, meaning something is wrong with them. Okay, they're broken, something. A telephone is randomly selected and is removed from the shipment, which means we now are working with, 7. It's found not to be defective. So if there are 3 defective ones, 8 minus 3 is 5. That means that there are 5 not defective, meaning they are perfectly fine. Okay? So we are pulling out of our shipment, whatever it is, we're pulling telephones out and we're not removing them. So the first time it's found to not be defective, the first time I pulled the telephone out, I had a 5 out of 8 chance of it being perfectly fine. When we remove that, we now only have 7 telephones in our container. The second telephone is randomly selected from the remaining, meaning there's only 7 total now. What's the probability of it not being defective? Well, we removed one of the 5. So now we only have 4 phones out of 7 that are not defective, which is option B. So remember, this is probability without replacement, meaning they're not putting the phone back in. They're taking it out of the package, examining it, and they're saying, oh, okay, these aren't defective. Let's pick another one, but not put the broken one back, okay? That's all they mean. So the correct answer is B. Number 12, an urn contains 5 white marbles. Let's write that down. So 5 white marbles, and it contains 6 green marbles. Which of the following would increase the probability of randomly selecting a white marble? Well, if I want to increase my chances of selecting a white marble, I should probably increase the numbers of white marbles only. Like, why would I add other colors if I'm trying to get more white marbles in this bag and pick those? I want more of them. Increasing the numbers of green marbles, that would increase my chance of picking a green one. I don't want a green one. I want the white marbles. Then it says decreasing the number of white marbles and green marbles by the same amount. If I want to increase my chance of randomly selecting a white marble, that's the only thing I want to mess with. I don't want to touch the green ones. I want them to stay the same or get less. I want to increase the number of white marbles. So the correct answer is A only. And sometimes in these problems, we have a hard time saying, oh, the answer is only A. But in this case, there is only one correct answer. Number 13, a coin is selected from a box containing 2 different types of coins. The probability of selecting the first type of coin, so the first type of coin, number 1, is 3 times the probability of selecting coin number 2. So coin number 2 just has a random X. Coin number 1, I have 3 times the probability of picking that one. Okay. It says there are 240 coins of the first type. There are 240 coins of coin number 1. How many coins are the second? So how many coins in the box are the second? Well, look at this one. Coin number 1 is 3 times coin number 2, but it's also equal to 240. So that means I can set 3x equal to 240. And when I divide by 3, I get 80, which means x is 80. Well, if x is 80, that's how many of coin number 2 are in the box. So being able to kind of write some visuals down, it's going to make it a little bit easier to solve your problems. Just build an equation. Number 14 is not as difficult as it looks, okay? Number 14 it kind of looks intimidating. It says if x equals 7, what is the probability of randomly selecting a number from the set that gives you all these x's and stuff, and it will be even. All you have to do is plug this 7 in. So the first number in the set is x minus 5. So x minus 5 or 7 minus 5 is 2. Then we go to the next one, 2x plus 4. So 14 plus 4 is 18. Then we have negative x, which would just be negative 7. X plus 5, which is 7 plus 5, which is 12. And then x plus 3, which is 7 plus 3, which is 10. All I did was take x and plug it in. So now I see 1, 2, 3, 4, 5 total numbers, and I'm looking for which one is even. Well, 2 is even, 18, 12, and 10, which is 4 out of 5. So I have a 4 out of 5 chance of selecting an even number. Number 15, Aiden's work schedule for the week is represented by the table. If this schedule remains the same for 4 weeks, and if a day from the 4-week schedule is selected at random, what is the probability that the day selected will be scheduled to work? So right now he has a total of 7 days he's working with. Well, we're looking for which one he's going to be scheduled to work. So he's going to work 1, 2, 3, 4 days. So 4 out of 7. He has a 4 out of 7 chance of being selected to work. Number 16, which of the following is not representative of a probability? Remember, the thing about probability is probability must always equal 1 or be less than 1. Like, this is part of a probability. If I look at option D, this number is greater than 1. It can never be a probability. Probability must always equal 1. So I have to make sure that I know, okay, it's got to equal 1. Oh no, I just unplugged my smartboard. Hold on. Okay, so sorry about that. Probabilities must always equal 1, which is why 16 is definitely out because it is over 1. All right, next one, number 17. 17 says a box contains red and black cards. The probability of selecting a red card is half the probability of selecting a black card. What is the probability of selecting a black card? So I'm going to do red and black. So let's say that there are X numbers of black cards. Well, if the probability of selecting a red card is half of that, then that would mean that the red is 1/2 X. We want to know the probability of selecting a black card. Well, in working with probabilities here, we need to make sure that we can solve for how many black cards there even are. Well, if we add the red cards plus the black cards, that equals the total number of cards in the bag or the box. Well, the red card is half of the black. So I'm going to put 0.5x plus the black cards, which is just x. And the total when working with probability is always 1. So now I'm going to combine. Half an x plus 1x is 1.5x equals 1. So when I divide by 1.5, x is equal to 2/3, which means if x is 2/3, that is the probability of selecting a black card. So the thing about probability is that it should always add up to equal 1. The total is always 1, which means it's complete. It's not missing any pieces. All right, number 18, one of the 3 cards must be selected to continue a game. The probability of selecting the first card, so the first card's probability is 2 out of 5. The probability of the second card being selected is 1 out of 8. We want to know the probability of card number 3. I'm going to put X. We don't know the probability, but we do know that we have to select a total of 3 cards, which means when we add all the probabilities together, they should equal 1. So remember, add your probabilities, they will equal the total. When working with probability, the probability would always be 1 or 100%. So I'm basically just building another equation. So I don't want to deal with fractions. So I'm just going to put it in my calculator because you know what? There's no shame in my game. I'm putting it in the calculator. I don't care. I don't care if you can find common denominators, make it all pretty. Does not matter. Okay. So when I add these fractions, I get 0.525. So 0.525 plus x equals 1. And when I subtract that from 1, I get 0.475. Well, all of my answer choices, so 1 minus 0.525, I get a decimal. Well, I want to make that a fraction. Math, enter, enter. It is 19 over 40. So I'm going to let my calculator do all the difficult thinking for me. I don't want to waste my time. So it's okay. You don't have to be intimidated by fractions. Just use what you have. So these two problems, number 17 and 18, they are very similar to each other. Remember, probabilities add up to 1. Number 19, I think, is the worst question on this practice because it is horribly worded. And I swear, they purposefully word these so terrible to just make you quit because reading this question is terrible. I'm going to read it to you, and then we're going to kind of cross out some words that don't make sense. It says, in a department store, there are X items on sale at a discount. If a total has 171 items on sale at the store and the probability of an item not on sale at a discount is 2/3, what is the value of X? Like, this problem is torturous. And the reason it is a pain is because the term that it's using, on sale, they really just mean that it's for sale. Like, we are selling this and there are X items at a discount. Like, when we hear the word sale, we think, oh, sale means discount. They're purposely wording this horrible, so you think the problem is difficult. So 2/3 of the stuff is not on sale at a discount. So right here where it says not on sale, I'm going to read this as not for sale at a discount. Okay, so 2/3 is full price, basically is what it's saying. Well, if 2/3 of the items are full price, that means that 1/3 of the items are at a discount. They have discounted them. Well, there's 171 items total. If 1/3 of those items are on a discount, and I want to know how many of the 171s will be sold at a discount, I'm just going to multiply 171 by 1/3 to get 57. So there are 57 items that are being sold on a discount. So this problem is horribly worded on purpose to make you think you can't do it, but you can do this problem. It's just worded very poorly. Hunter has collected 35 science books over the last 2 years. 5 of these science books cover biology. What is the probability of selecting a biology book? Well, he has a total of 35 books, and it just said 5 of them have biology. That is not an option. So when I reduce 5 over 35, I get 1 over 7. So I have a 1 out of 7 chance of selecting a biology book. Number 21, sorry, I was at number 20. The results of a career interest survey for this mathematics club is provided in the table. If a student is randomly selected from the group, what is the probability that the student will be interested in aviation? Okay, well, we have a total of 18 kids that are interested in aviation. So we know that 18 should be our top. However, we need the bottom. So what we want to do is basically add all of the kids that are tested. Okay, so in order to put the number on the bottom, we have to add all the kids that participated. Well, if we add up all the number of students, we have 200. So 200 is our denominator. However, that's not an answer choice. So 18 over 200 reduces to 9 out of 100, which is how many students are interested in aviation. Remember, always reduce your fraction. Probability is always simplified because it represents a ratio. The blood types of 150 people were determined for a study below. If one person is randomly selected, what is the probability that they will be either type A or type AB? So here's the trick. We don't care if they're A or AB, we just want them to be one of the two. Well, the first thing we have to know is the total. So there are 150 people. So we'll do type A first. So I will put A up here. 150 people. Well, I'm going to look over here for type A. There are 67 people with type A. All right, type AB, there are still 150 people. Looking at my choices, I have 6 that are AB. It's either or probability. So remember, you always add your probabilities together. 67 plus 6 is 73, and looking at my answer choices, it is D. Remember, when you're working with or probability or non-overlapping, you add. If it's overlapping or combined probability, you multiply.